Hello, Griffins. Milks here. Lecture video number 5, naming ionic compounds. This will go very much like it did in bell work and in class. Nomenclature of an ionic compound. There are 3 examples on this page, so you might want to watch it once, save some space, uh, watch it thoroughly, know how to put in everything in the little bit of space you got, and conserve just a little bit. Okay? So, first things first, I have a first name, a middle initial, and a last name when I name ionic compounds. The middle initial is for my middle metals. If I am a transition metal with more than one charge, I need a Roman numeral to tell me which charge I am. Remember, the Roman numeral is the charge. First example, FeCl2. So let me look here real quick. Periodic table, I find Fe and I find Cl. Okay, a few things we need to know. Remember back in the POGL, positive comes first, so I know Fe is positive, but oh man, I have a +2 and a +3. And I need to figure out which one I'm going to use. And Cl, I have all of these choices here, but I know it goes positive and then negative, and I only have one negative choice. So I know that Cl is going to be a -1. And then I need to figure out, is iron going to be a +2 or a +3? And what I do to do that is I say, hey, listen, there are 2 chlorine atoms. So this -1 times 2 gives me a -2 total negative charge. So now it makes it a little bit easier. Do I pick a +2 or a +3 for my iron to figure it out? You tell me. Do I +2 cancel out a +3? I'm sorry, a +2 with a -2 or a +3? And now we can get on to naming it. So the first name is just the name of the metal. So Fe is iron. Middle initial, in this case, the Roman numeral is the charge, and it is +2, because that +2 is what's going to cancel out with that -2 for the chlorine. So I'll use the Roman numeral 2. Then the last name is going to be the name of the nonmetal, and then I add the suffix "ide." So chlorine becomes chloride. So when I put that all together, I have iron 2 chloride, which is a much different thing than iron 3 chloride. Okay, we got to be specific. Okay, next example. Remember I told you there would be 3 examples. Next one is CaCl2. Now this one's actually just a smidgen bit easier because when I look at the periodic table, and I didn't bring the tile up on the board for this time, calcium only has one choice for its ions. It's only a +2, period. So I don't have to put that Roman numeral. It's not a middle metal. It doesn't need a middle initial. So Ca, I look it up as just calcium. Cl is chlorine, ending in ide is chloride. Done. Calcium chloride. That's simple. Very good. Now let's do one with a polyatomic in it. And believe it or not, these are actually a smidgen bit easier yet. Okay, because I'm still going to name my metal. And to name the metal, Ca is calcium. And then I look up table E to find CO3. So table E is how I find CO3 because I can't find CO3 on the periodic table. I got to go to table E to find that. And I take the name of the polyatomic, and I don't have to do nothing to it. I just take it. And CO3 is carbonate, so it becomes calcium carbonate. Now while we're here, I drew this parentheses on here just so you would see that help us figure out it's a polyatomic ion. You may well very well may see that this is CaCO3. You might see that normally without a parentheses because there's only one CO3. So because there's only one, I don't necessarily need a parentheses. That's there to kind of give us a hint that early on that it is a polyatomic till we get really good at those. Okay, charge cancellation. When I go backwards, I can use the charges to help me figure out what the formula is when I go from the name. Okay, so there's some quick rules we got to go through. First, I need the element symbol. So the element for sodium is Na. And this chloride comes from chlorine if I go backwards and lose the ide. So that's Cl. There we go. 2, I need the charges. Looking on the periodic table, the charge for Na is +1. The charge for Cl is -1. And in this example, I don't necessarily, this next step might convolute things a little bit, but it's good to use this, figure out this step with an easy problem. I can see that I need one -1 to cancel out with one +1, which is a 1-to-1 ratio. Okay, so I think we intuitively know I need one of each, but here is the method for figuring it out for sure if we're not quite right. And it's a largest common factor type of a thing. I need 1 + 1 to cancel out with 1 - 1. And the trick, the shortcut to get there is to just take the charge and cross it down without the sign, of course, because the subscripts are just the numbers of atoms. So I don't have a positive number of atoms and a negative number of atoms. I just have a number of atoms. So the Cl, the one on -1 on the Cl, I'll bring the 1 down to the subscript on the Na, and I'll take the 1 from the Na and bring it down to the Cl. I have 1 and 1 to 1-to-1 ratio, and I can rewrite this with the atoms right next to each other to show that they're in a compound. They need to be close to each other without the space. NaCl. I notice I don't have to write the 1s in chemistry usually. So when there's a subscript of a 1, I don't need to write it. It's a little redundant. If I wrote the letters for the element, that implies that the element is there. There's got to be at least 1 if I write the letters. Okay. All right, slightly more challenging example. I have calcium chloride. Okay, name-wise doesn't look any different at all, and you'll see as we go why it gets a little bit tricky. Now, element symbols, calcium is Ca. Chloride, take off the "ide," is chlorine, Cl. Now I have to find the charges, step 2. Calcium is a +2, and chlorine is a -1. Now, this is not as easy as the first one, but in the fact that it was 1-to-1, I didn't have to do anything. This time I have to do something, but I think it's still kind of intuitive about what we have to do. How many -1s do I need to cancel out with that +2? I have a feeling we're all going to say 2, and the crisscross method will get us there real quick if we're not sure. So I'm going to take the 1 from the chlorine and drop it down to the subscript on the calcium. Notice I lose the sign. And same thing with the 2 on the calcium. I'm going to bring that down to the chlorine and lose the sign. And I have Ca1, Cl2. And when I rewrite that, I don't need the 1. I got Ca, Cl2. Tighten up those element symbols. They got to be right next to each other to show that they're bonded. Okay, no big space in between them. Here we go. One last one. This one has a Roman numeral, so it's even slightly more complex. So I have iron oxide, first part. What element symbols am I dealing with? I got Fe for iron. I got O for oxygen. That's good. And now the charge for iron. I see I have a +2 or a +3, but the Roman numeral in the name, Roman numeral 2, the Roman numeral is the charge. So I know instantly this going this direction that the charge is 2. I don't have to figure that out. I don't have to guess because the Roman numeral is the charge. Oxygen has a charge of -2. It's the only negative choice that we have. As a matter of fact, it's really the only choice we have. So I crisscross these. I bring the 2 down from the oxygen. I take the 2 from the iron. Notice I'm losing the signs. And I have Fe2O2, and here comes the last piece that I did forget to mention earlier, because it wasn't relevant then, even though we did it, is to reduce. This is really a 1-to-1 ratio. So I could actually write this FeO, because for every 1 iron I need 1 oxygen to cancel out the +2 and the -2. I only need 1 -2 to cancel out with 1 +2. And we just rock and rolled right through nomenclature forwards and back of ionic compounds. So you do have some practice pages in your packet to work on. If you haven't finished them, I want to see you do these. Do as many of them on your own as you can. You will need your periodic table. Back it up with a Google Classroom assignment, and we're all done. See you guys tomorrow in class.